Alright, we're doing law of cosines today, okay? If you remember the scenarios that I told you that could happen, and two of them were solved by law of sines, and two of them were solved by law of cosines. Who remembers what the two scenarios are when we're solving law of cosines? Ooh, okay, cool. Three sides. So when we have three sides, which means it's side, 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 and what was the other one? Two sides and an angle. Can you be more specific?
Like the two sides and the angle is in
Two sides, and their included angle, which would mean side, angle, side. Right? So these are the two scenarios that we can use for, that we're going to need to use law of cosines for. If you're given three sides, or if you're given two angles, and the angle that's created by the two sides. Okay? Alright, we are going to derive the formula for law of cosines just like we did the law of sines. So you ready? Alright. Just draw the following diagram. This is your y-axis and this is your x-axis. And we are going to have a triangle drawn where this is angle A. This is angle B, and this is angle C. And this pen's not very good. Let's switch. Alright. There's a reason why I put this on the coordinate plane. Okay? Let me ask you. If I were to ask you for, hold on, the coordinate of this right here, of this point right here, what would you tell me it is? B. This point right here, what would it be? You can't use you can't really come up with random numbers. I agree with the 0.
like 5 0. Like 5 0.
Yeah. AB. Well, let me ask you something. This diagram, you should be able to put even more to it. Look at the triangle. What you got, Victor? Small c. Why is it small c? It's the side length that's opposite from angle C, right? And then that means that this is small b, right? And this is small a. So now, I will repeat the question. What will be the coordinate for this point? C, comma 0. Cool? Alright. Trust yourself next time. Okay? Alright. Now, this one's a little tougher. But can anybody give me the coordinate for angle C in this case? What you think? No, good try. Okay? Let's use X and Y. Okay? Let's not use H. X and Y. And it's very simple. You're going to be like, really? That's what you were looking for? Some distance X, some distance Y, right? Sorry, it was not meant to trick you. Like, I was just like, okay. I know, it's kind of hard because everyone wants to use what you have on the diagram. Exactly. So, it's not that it was hard, it's just that it was that obvious that you're like, really? Come on. Okay. Alright. If you want to draw this to help you out, you can. Then you can say that that's Y. And then you can say that that is X. Right? Just to kind of help you out if you want to. You don't have to. Alright. So here's what we're going to do. We're going to be using angle A. And since we're talking about the law of cosines, we're going to say that cosine of angle A equals to what? What do you guys think? Not quite. X over B. Why is it X over B rather than C over B? because we need a right triangle in order to do this. If you use C, then it's not a right triangle. Do you guys agree? So for it to be a right triangle, the x was the distance from here to here, and then we formed a 90 degree, right? Oh, that's B, sorry. Okay. Alright. I want you to also tell me what sine of A would be. Y over B. Okay? Alright, now what we're going to do is solve for x and y. So for x, here we're going to have x equals B times cosine of A. And for y, we're going to have y equals B times sine of A. Cool? Alright, the law of cosines, the way it works is since we're dealing with angle A, that's going to help us find the length of side A. So in order to do this, what I'm going to do is we're going to go back to algebra, and we are going to find the distance from here to here in order to find the length of A. Does that make sense? So who remembers how to find distance between 2 points? What's the distance formula?
Square root of x2 minus x1 squared plus y2 minus y1 squared.
Good. Alright, so we're going to say then, in this case, since we're looking for A, we're going to say that A equals to the square root of what? Use what you have. Use the diagram. C minus x? What's up? Are you okay if we do x minus c? Same thing? Are you guys okay with that?
Sure.
Square. Plus what? Y minus 0 square. Are we all okay with what we did? Yeah. It's you take both of the x coordinates and subtract them and square them. You take and then you add the two y coordinates and subtract them and you square them, right? That's all it is. We're going to simplify this. You guys ready? A equals, okay? What I want you to do is actually, you know what x and you know what y equals to. We're going to substitute it in, right? Because up here we solved for x. So instead of x, now you're going to write all this. And instead of y, you're going to write all this. Okay? So this becomes square root of b times cosine of a minus c squared. Cool? Plus y is b times sine of a. Do you really need the minus 0 anymore? Not really. So we're going to put square. Okay? Alright. We're going to continue to simplify this. A equals the square root of. We're going to go ahead and not factor this out, but distribute all these out. What is b cosine a minus c squared? Well, if we multiply b squared times b cosine of a times b cosine of a, you get b squared cosine square of a. Right? If you multiply that times that, what do you get? This times that. And that's going to happen twice. You guys agree? Because then you're going to multiply that by that. So minus 2c, which by the way, that should be a lowercase c. I know I've been writing them big, but it's a lowercase c. Don't think it's the angle, right? Okay? It's not the angle. Okay? This should be lowercase. I'm sorry. I'm writing pretty big. It's the side, not the angle. Okay? 2c b cosine of a. Right? And last but not least, what's negative c times negative c? Plus c squared. So that takes care of this, right? Plus, what's b sine a squared? Alright. Are we okay with what we got so far? In order to get rid of the square root, we're going to square both sides, so this becomes a squared equals. I'm going to rewrite this in a different way if it's okay with you guys. Okay? Same thing, but I'm just going to rewrite it as b squared cosine square of a plus b squared sine square of a plus c squared minus 2cb cosine of a. All I did was just rearrange the order. You guys okay? All right, Victor, can you tell us what you noticed that's going to help us out here?
The B squared, they have the identity cosine square root of A is cosine square root of A.
Wait, you mean you can't just forget your identities in this class?
Oh my God.
Of course not, okay? So, check this out. If you factor out a b squared, then you have cosine square of A plus sine square of A. And then I'm just going to rewrite the rest. Plus c squared minus 2cb cosine of A. And now, guess what? That identity is called the what kind of identity? The Pythagorean identity is equal to what? 1. So that means that a squared equals to b squared plus c squared minus 2cb cosine of A. And this right here is known as the law of cosines.
That is not easy. That is easy.
Okay. All right. Yes.
I like your pen.
Thank you. Anj gave it to me. He went to Brazil and he got me a... What is this? Is this a parrot?
Parrot.
No, this is not a parrot. What is this?
Parrot. That's a mockingjay.
No, this... What is this? This is not a parrot. No. Is it a parrot? I've never seen a parrot with blue wings. Okay, whatever. We'll figure it out. Anyways, alright. So, here's the thing. I know that was a lot of work. Guys, I'm not going to be asking you to derive it. I'm going to ask you to use it. You're gonna just use it. I'm not going to ask you to derive it. I know this was a lot of work. Now, you could redo all this, or I could tell you that there's 3 law of cosines. Are you ready? Okay? Can I switch the page? It is? Cool. Alright. Here is the law of cosines. Sorry. Alright, I'll use the back of this page. I'll be friendly to the environment. So here's the law of cosines. A squared equals b squared plus c squared minus 2bc cosine of A. Okay, that's one of them. Yes?
Wait, I have a question.
Mhm. Yes.
So, you said you're going to give us more. Is this one of those things where we just have to pick which one works best?
Correct.
Oh, no.
Not which one works the best, but which one will work for what you have.
I always pick
Okay? Alright. I'm going to show you the second one, and tell me if you notice anything. It's the same thing, but with what? Okay, so then let me ask you, who can tell me what it would be for c squared? Go ahead, Melissa. Very good. Okay. In reality, it's the same thing. You will notice that whatever side you're looking for, that's the angle that you're going to use for the cosine. And then the others are the two sides that you're not using in between those. Okay? Look, side B, angle B, side A and C. Looking for C, you use angle C, and then you use the other two sides here. Okay? Alright. Any questions so far? Okay, before we actually get started with some problems, I want to talk about something called the converse of the Pythagorean theorem. You know what the Pythagorean theorem is, right? A squared plus b squared equals c squared. And what does that tell you? That you have a right triangle. Who remembers what the converse does? What does the converse of the Pythagorean theorem do? I'll give you a hint. You still have a squared plus b squared, and you still have the c squared. Not equal? Well, if it's not equal to, then you would tell me that it's not a right triangle, right? But let me ask you, then how would you know then if something is acute or an obtuse? Alright, so let's talk about this. If it's greater than, so if you take a squared plus b squared and it's greater than, you have an acute triangle. Okay? If it's less than, then you have an obtuse triangle. And if it's equal to, then you have a right triangle. And just by the way, I'm pretty sure you know this, but C has to be the longest. The longest side when you're using this, okay? Where A and B. Alright. Are we okay with that? If you didn't see that prior to this class, does that make sense? Okay. Now we're going to practice. Okay, so let's do an example. So example number 1. A equals 8 feet. B equals 19 feet. And C equals 14 feet. Okay? I gave you 3 sides, no angles, which means that you have to find all the angles. So when you draw your diagram, it doesn't have to be drawn to scale again. I'm never going to be checking to make sure that this is actually what you put. I'm not going to take out my protractor or my ruler to measure it. I'm not, okay? So, you know that A is 8. You know that B is 19. And you know that C is 14 feet. Cool? Alright. You have to apply the law of cosines, right? And here you get to choose wherever you want to start. Because you have the 3 sides, you can choose wherever you want to start. Okay? However, okay, here's what I like to do. You guys ready? I like to use this Converse to find out what kind of triangle I'm looking for. Okay? If I'm looking for a right triangle, an obtuse, or an acute. I'll tell you why in just a second. So, the largest is 19, so that's going to be 19 square. And then 8 square plus 14 square, right? 8 square is 64 plus 14 square is to what? 56, right? Oh yeah, what's 256? That's 16. Okay, 100 and what? 96. And 19 square is? Can y'all see that? Hold on, I'm gonna scan this so you need to be able to read it. Hold on, we'll get there. And 19 square is what? To what? 361. Obviously, when you add this, you're going to see that this is... So what does that mean? Obtuse. Okay? Now, when you have an obtuse triangle, I always like to find the largest angle first. So in this case, which angle are we looking for? B. The reason why I like to find the largest angle, it's because of those scenarios that we ran to in the law of sines. Remember? What are those scenarios called? The ambiguous case, remember? I like to find the largest angle first because if I find the largest angle and it makes sense with the sides that I'm given, then I'm good. If not, then that's going to tell me something else. Okay? But we'll get there. You guys ready? So, if I'm looking for angle B, I'm going to use the law of cosines, and I'm going to use this one right here. Cool? So that means, do you have side B? Yes, you do. That is 19 square equals to 14 square plus 8 square minus 2 times 14 times 8 times the cosine of B. Okay? Notice how I didn't really look at the actual law of cosines. Once you figure out, all these numbers are really easy to plug in because 14 and 8, 14 and 8. Cool? it really doesn't matter the order that you put them on, right? Because you're multiplying and you're adding. Alright, so to figure out what this would be, that would mean that you would have 19 squared minus 14 squared minus 8 squared divided by negative 2 times 14 times 8, and that would equal to cosine of angle B. Do you guys agree? Right? There's no point of doing any computations now when you're gonna plug all this in your calculator. By the way, you guys are gonna need calculators like for this test, so make sure you grab a calculator. Okay? Do the inverse. All over negative 2 times 14 times 8. Very important that you don't forget that you had a negative when you divide out. Okay? If you forget to put the negative, you're probably going to get a different angle, which is going to cause you to do the entire problem wrong. Okay? Plug it in. Tell me what you get. 116.8 degrees. That looks like a 1. 116.8 degrees. Okay? Yes. Absolutely. And I encourage you to do that. Once you have one angle, now you can use the law of sines. Do you guys agree? Because you have all the other three sides. And in my opinion, the law of sines is just easier to use, personally. So once you have one angle, now we know that this is 116.8 degrees. Then you would just have to use the law of sines one time to find another one of the angles. And then you can just do 180 minus those two angles and you get the third angle, right? So I want you to go ahead and try that on your own. Apply the law of sines and find the other two missing angles.
So if we're using the law of sines,
Check your answers when you're done, please. Not that I know of, actually. I don't know. Alright, we're going to do another example. Example number 2. B equals to 9 meters. C equals to 12 meters. And angle A equals to 25 degrees.
Wait, can we try this one? Oh, wait, never mind.
I actually wanted to show you guys this one as a group because it's a little different. What scenario do you have in this? Side, angle, side. Cool? Alright, so just draw yourself a triangle and plot information in. So let's say that this is 25. Let's call these A, B, and C. Where this is 9 meters and C is 12 meters. Okay. What should I do here? What's the first piece of information the only thing of information that you can find at the moment? The opposite side. That's the only thing I can do at the moment. I can't find the other two angles. The only thing I can find at the moment would be side A. Do you guys agree? So it's going to be A squared equals 9 squared plus square minus 2 times 9 times 12 times the cosine of 25 degrees. Right? Because you already have A. So once you plug all that in, tell me what you get. Well, actually, you can knock two birds with one stone. You're going to eventually need to take the square root of it, right? So go ahead and take the square root of it all in one step. So that means that A equals to the square root of all that, right? So A equals 5.41, and it's meters, right? So now you have A. Alright, now, I am going to tell you that you have to do the following. Are you guys ready? Okay. I want you to apply the converse to know what kind of triangle it is. Here's the reason why. Because if you have a side, the three sides in an angle, some of you guys are going to use the law of sines to find this angle, and some of you guys are going to use the law of sines to find this angle. When you do that, you both are going to get different answers. And then you're going to run into why. you need to find out if you have an obtuse or an acute triangle before you start doing this, okay? So, you applied it, Kevin. What kind of triangle should we get? Obtuse. So we have an obtuse triangle, which means that according to these measurements, which one is the angle that we need to find using the law of sines? C. Okay? If you find angle B first, I am telling you, you are going to get this wrong. Okay? You're going to get something different. Because of the ambiguous case that we studied during law of sines, but it wouldn't work. Once you find, and we will do it. Once we're gonna do it both, but I will show you at the end result why it wouldn't work. Okay. So I want you to find angle C first. So we're gonna do law of sines. So that means we have 12 over sine of angle C equals to A, which in this case is 5.41 over sine of 25 degrees. What's that? Bear with me. Okay? Remember, it's opposite from the largest side. So since this is your largest side, the opposite angle will be C. Okay? Yes?
So since you're solving for the biggest angle now, what if you had an acute triangle?
Bear with me, all of you guys. Like, all those questions will be answered. Okay? Ready? Okay? So here's what I want you to do. Because you guys are having all those questions, I want you to do this on this side, but on the opposite side, I want you to do 9 over sine B equals to 5.41 over sine of 25. Okay? I want you to do both scenarios. So if you solve here, you're going to have sine of angle C equals to 12 sine of 25 degrees divided by 5.41, which means that C is equal to the inverse of sine of 12 sine 25 degrees over 5.41. Cool? Plug that in the calculator and tell me what you get. 69.6. Wait.
I got 20.6.
You got 69.6, but hold your thought. Okay? I got something different for that. Hold on. Let me check my work. What you get? 69 what? 0.6? Okay. You guys ready? Because we discovered that this was obtuse, you're going to use the reference angle. This is 69.6, right? So the reference angle would be located here, which would be how much? Oh, I'm sorry, yes. 110.3 degrees. 0.4. Sure. Sorry. Okay?
Why is that?
Because we did, remember how we did, and some of you guys didn't do it. But if you didn't do it, you were supposed to do the converse to find out what kind of triangle you had. When we did the converse, we found out that it was obtuse. So when you're finding the largest angle, you're looking for an obtuse angle. Your calculator can only do quadrant 1, which means quadrant 1 would be an acute angle. And you have to use the acute angle as a reference to obtain that obtuse angle. Does that make sense? It has to be, yes. Correct. Alright, so that means if that's C, what would B have to be? Because you already have angle A to be 25, angle C to be 110.4, so angle B has to be what? 44.6 degrees. Alright, so we're going to go up here and we're going to plug all those in. So B is 44.6, right? And angle C is 110.4. Looking at that, is the largest angle opposite of the largest side? Good. Is the smallest angle opposite of the smallest side, which was 5.41? So, is this correct mathematically?
Yes.
Good. All right. Let's go to this scenario.
So this is the wrong one.
Mhm. So if you don't want to write this down, you don't have to, but just kind of follow me. All right. So, if we cross multiply here, we get sine of b equals to 9 sine of 25 degrees over 5.41. Right? I'm going to have to do the inverse, so angle B equals to the inverse sine of this whole mess. Can somebody do me a favor and plug this in your calculator? What was it? 44.7. Cool? Degrees. And based on that information, you knew that A was 25, right? And now you have B. So to find C, we would do 180 minus 25 minus 44.7, and what would you get? 135.3? 110? No. Just wait. Okay, what'd you guys get? One what? 110.3? Hold on. Hold on. Pause. Why is it working? Hold on. I'm doing something wrong mathematically. Okay, so here's what happened during the other class. You guys remember when you plugged this into your calculator, you got 69.6? So then if you use that angle, right? So 180 minus 69 plus 6 is what? 180 minus 69.6 minus the 25 that you were given, right? That would mean that the third angle would have to be 85.4. You guys agree? Right? So then when you draw your triangle, that would mean that this is 25. That would mean that C was 69.6, and that would mean that this is 85.4. Correct? And then what is going on? Hold on. Do I have to redo this entire problem on my own? Something should not work. What is... And I need to teach you this, so hold on. Because I don't want you to run into this problem. Yes? Okay. What is the formula for every triangle? Area equals 1/2 base times height. Right? And some triangles are nice enough to where you already have the height given to you, or that it's easy enough where you can find it yourself and you can solve it. But sometimes it won't be that easy. So what if I told you that there's a formula that can help you find the area of an oblique triangle? What does that mean? It's a triangle that's just not right. Okay? So we can find the area of a triangle that is not right. Okay? There's two formulas that we're going to use. Which one should I teach you first? Alright. I'm going to show you the law. Heron's formula. Heron's formula, I don't know if that's how you say Heron.
Can we just say formula?
Heron's formula. Okay. What? Alright. Area equals to the square root of s times s minus a times s minus b times s minus c, where s is equal to a plus b plus c divided by 2. It's s minus a, s minus b, and s minus c. Let me ask you first of all, what is a, b, and c? So this one can be used when you have side, side, side. Do you guys agree?
Yes.
Okay. So let me find a good example in the book. Actually, go back on notes. We had a triangle with SSS, right?
Yeah.
What was that? Can you give me the measurements? How much was it? 8?
Yeah. B was
19.
C was 14.
C was what?
14.
14. Find the area of that triangle. (19 plus 14 plus 8 divided by 2). And then plug it into the formula, and you should be good to go. What you get? Area equals, S equals 20.5, right?
Yeah.
And then area then would be,
Wait, with this triangle, can't you just self-eliminate using
sure you can. But then let me ask you, how are you going to know the distance from here to there to help you figure that out? Or the distance from there to there? Right? I mean, you can do it, but there will be more math to it, okay? So it would be 20.5 times 20.5 minus 8 times 20.5 minus 14 times 20.5 minus 19, okay? Do you guys remember how on your calculator you can store, so you don't have to retype every time?
Yeah.
So what I would have done is, first of all, I haven't found S, so let me show you. I would have done 19 plus 14 plus 8 all over 2. And I got this much, which if you turn it into a decimal, oops, it is 20.5 like you said. Who remembers how to store?
No. You can just do getting minus.
How about we do S, right? STOX. So now when I'm typing this in, I'm times X minus 14 times X minus 19 times X minus, what am I missing? 8?
Yeah.
So that's all my 3 sides, right? Enter. Area equals 40, 50, right? 50, I don't know what units were there. Was there any units on that problem?
Well, the problem you give it to
Feet. So feet square. And I will be looking for units here because you're talking about area. Yes. For this, because it's not sides or angles, it's the 3. So the only time you need 2 decimal places is when you're looking for a side, and 1 decimal space when you're looking for an angle. Anything else, the 3 decimal rule still applies. This would have to have 3 decimals, so never mind. This would be what? 49.984 feet square. Not that. Good job. Okay? Alright. Heron's formula. Good? Easy? Alright. Yes, you do. There's a third one, and that's in case you have side, angle, side. Okay? Yes?
all the stuff we're doing right now, how much do we have to memorize? All of it.
All of it. Okay? Alright. I don't know if there's a name to this one, I just know the formula. Okay? Area equals to 1/2 BC times sine of A. Or it equals to 1/2 AC sine of B. Or it equals to 1/2 AB sine C. Cool? In other words, is the two sides and their included angle. Okay? So let's say I gave you something like, yeah, let's go back on notes. So we're going to say 9 meters, 12 meters, and this was 25 degrees, I believe. Okay? So when you do this, it's going to say 1/2 times 9 times 12 times the sine of 25 degrees. Which is 54 times the sine of 25, which is, if you plug it in, I have no idea, 54 sine of 25. 22.821, and I think this was meters squared. And that's your area. This needs to be memorized. Okay? Right? This has to be memorized. And if we go back in your notes, this 3 have to be memorized. Yeah. Side angle side. This one and this one. Okay? Alright. Here's the homework for tonight that is due next time. So write it down, take a picture or something.